In June of 1816, farmers in New England woke to find ice on their fields. Snow fell during a month that should have felt like summer. Young plants blackened overnight. Across the Atlantic, rain seemed to forget how to stop. Grain rotted, food prices climbed, and families wondered whether the seasons themselves had somehow broken. They called it the year without a summer. Some Americans gave it an even less subtle name. 1800 froze to death. But the strangest part was that the disaster had begun more than a year earlier on the other side of the planet. And its consequences would reach from Indonesian villages to European bread markets, American farms, migration routes, paintings, inventions, and one stormy gathering that helped produce Frankenstein. This is Oddly Human History, the show about ordinary people dealing with a past that refused to behave normally. Today, we are asking a simple question with a planet-sized answer. Where did summer go? Our story begins on the Indonesian island of Sumbawa. There stood Mount Tambora, a massive volcano that had been restless for several years. In April 1815, that restlessness ended violently. The eruption reached its catastrophic climax around the 10th of April. Explosions were heard hundreds of miles away. Darkness covered surrounding areas as ash fell from the sky. Pyroclastic flows swept down the mountain, and the eruption generated destructive sea waves. Tambora was not merely a large eruption. NASA describes it as the largest eruption in recorded history. The blast removed a substantial part of the mountain and left behind a huge caldera. Communities close to Tambora were devastated. Thousands died during the immediate disaster, and many more died from the famine and disease that followed. This is important to remember, because the year without a summer is often told as a collection of curious European weather stories. For people living near the volcano, it was not a curiosity. It was an apocalypse. The eruption also launched enormous quantities of material into the atmosphere. The most important ingredient for the later cooling was not simply the heavy ash that quickly fell back to Earth. It was sulfur dioxide carried high into the stratosphere. Their chemical reactions produced tiny sulfate aerosol particles. These particles reflected a portion of incoming sunlight back towards space. Imagine drawing a thin, almost invisible veil around much of the planet. Sunlight could still pass through, but slightly less energy reached the surface. A few tenths of a degree of average cooling may not sound dramatic. If your living room becomes half a degree colder, you probably do not begin writing a tragic diary. But global averages conceal local extremes. Climate is not a thermostat that turns every place down by exactly the same amount. Tambora's influence interacted with oceans, winds, existing cold conditions, and natural weather variability. The result was not one evenly chilled world. It was unstable, damaging weather, especially across parts of the Northern Hemisphere. In New England and eastern Canada, the summer of 1816 brought repeated cold snaps and killing frosts. Contemporary accounts describe snow in June and cold returning when farmers desperately needed warmth. Crops were planted, damaged, replanted, and damaged again. Corn was especially vulnerable. Hay became scarce, which meant livestock faced hunger too. A farmer did not need to understand stratospheric chemistry to recognize the problem. If the field produced nothing, the family and animals had very little to eat. Europe suffered a different version of the same crisis. Persistent rain, cold conditions, and flooding damaged harvests. Grain yields fell. Potatoes and other crops suffered. In many places, the effects arrived after decades of war had already strained governments, trade, and household finances. Napoleon had been defeated only the previous year. Soldiers were returning, economies were adjusting, and many poor families already spent most of their money on food. Then bread became more expensive. That short sentence hides an enormous amount of fear. Today, some shoppers can substitute one product for another when prices rise. A laboring family in 1816 often had far fewer choices. Bread and grain were not optional lifestyle purchases. When harvests failed across several regions, prices could rise rapidly. Hunger spread. Crowds protested in markets. Grain shipments were guarded or attacked. Governments tried a mixture of relief, regulation, charity, and force, with very uneven results. The weather was natural. The suffering was shaped by society. Wealthier households could absorb higher prices, move supplies, or purchase alternatives. Poor families could not. A cold summer was dangerous. A cold summer in an unequal society was catastrophic. The crisis also pushed people to move. In the northeastern United States, difficult conditions contributed to migration toward western territories, where land was advertised as more promising. Of course, no single storm or frost explains a mass movement. People migrate for overlapping reasons: land prices, debt, family connections, opportunity, politics, and rumor. But a ruined harvest can turn a possibility into a decision. Climate does not move people like pieces on a board. It changes the choices available to them. Meanwhile, in Switzerland, the terrible weather was interfering with a very different kind of plan. In the summer of 1816, a group of young writers gathered near Lake Geneva. They included the poet Lord Byron, Percy Bysshe Shelley, John Polidori, and 18-year-old Mary Godwin, who would later become Mary Shelley. Their holiday should have included boating, walking, and enjoying the landscape. Instead, cold rain repeatedly drove them indoors. To entertain themselves, they read supernatural stories and proposed that each person write a ghost story. Mary initially struggled to find an idea. Then, after conversations about science and the possibility of reanimating life, she imagined a student kneeling beside the creature he had assembled. That waking nightmare became the seed of Frankenstein. It would be silly to say that Mount Tambora wrote Frankenstein. Mary Shelley did that, through imagination, revision, reading, grief, ambition, and remarkable talent. But the eruption helped create the gloomy weather and the indoor circumstances surrounding the famous Ghost Story Challenge. A volcano in Indonesia altered the atmosphere. The altered atmosphere helped ruin a Swiss summer, and that ruined summer became part of literary history. Cause and effect rarely travel in a straight line. Sometimes they cross oceans, enter a drawing room, and wait beside a blank page. The gathering produced another important work as well. John Polidori's later story, The Vampire, helped shape the modern literary vampire. So that miserable holiday contributed to both Frankenstein's creature and the aristocratic vampire. Apparently, if enough writers are trapped inside by bad weather, popular culture should prepare for consequences. The Year Without a Summer is also connected to an early ancestor of the bicycle, although this part of the story needs a careful footnote. In 1817, the German inventor Karl Drais demonstrated a two-wheeled running machine. It had no pedals. A rider sat on it and pushed against the ground with his feet. The device is often called a draisine or hobby horse. A popular explanation claims that crop failure made oats expensive. Horses became costly to maintain, and Drais invented a horse-free form of transport in response. The timing is suggestive, and the food crisis certainly affected the cost of keeping animals. But historians debate how direct the connection was. Drais had broader interests in human-powered transport. An invention rarely has one tidy cause. The careful version is that the post-Tambora crisis formed part of the world in which the machine appeared. The careless version is that a volcano invented the bicycle. The careless version is more fun, which is exactly why it needs the larger warning label. Tambora may also have left clues in the sky. Large volcanic eruptions can produce vivid red and orange sunsets because aerosols change how light is scattered through the atmosphere. Paintings from the years around 1816 contain striking sunset colors, and researchers have examined historical art for possible evidence of volcanic effects. But paintings are not photographs or calibrated instruments. Artists choose pigments, exaggerate mood, follow conventions, and paint from memory. A red sky can be evidence, inspiration, or simply a red sky. The interesting point is not that every orange painting proves Tambora was present. It is that the eruption may have changed both the physical atmosphere and the visual world artists were trying to capture. People living through 1816 could not see the global chain. There were no satellites, worldwide weather models, instant news feeds, or diagrams of aerosol circulation. A farmer in Vermont knew that frost had killed the corn. A laborer in Europe knew bread cost too much. A writer in Geneva knew it would not stop raining. Few could connect those experiences to a mountain in Sumbawa that had erupted the previous year. Some observers searched for explanations in the sun. Others treated the weather as a religious warning or simply an extraordinary local season. Their information was local, but the cause was global. That mismatch made the event especially frightening. The rules of daily life seemed to have changed without explanation. Today, the year without a summer is a powerful example of how a shock travels through connected systems. Begin with an eruption. Move upward into the stratosphere. Reduce the sunlight reaching the surface. Disturb weather patterns. Damage harvests. Raise prices. Increase hunger and unrest. Push migration. Alter holidays, conversations, inventions, paintings, and books. Not every link is equally strong, but whether all mattered. Good history resists the temptation to turn one dramatic event into the climatic period. Everything. But good history also notices connections. Tambora changed the conditions in which millions of people made decisions. It narrowed some choices, opened others, and made everyday life more dangerous for those with the fewest resources. That is the deeper lesson of 1816. Environmental disasters do not arrive in an empty world. They enter societies with existing inequalities, fragile supply chains, political conflicts, and imperfect information. The physical event may be shared. The suffering is not distributed equally. The Year Without a Summer sounds like the title of a fantasy novel. It was real. Snow came when crops needed warmth. Families watched food disappear. Markets became battlegrounds. People moved. Riders invented monsters. An experimental machine rolled down a road without a horse. And high above all of them, invisible particles continued circling the planet. History often looks orderly after someone places it in a timeline. Living through it is different. It feels like opening the door in June, seeing snow on the ground, and realizing that nobody knows when normal will return. If you enjoy the strange human side of the past, subscribe to Oddly Human History. Our next story asks why fashionable Europeans once gathered in drawing rooms to unwrap ancient Egyptian mummies. It involved science, spectacle, empire, and the absolute certainty that someone at the party should have said, "Perhaps we should not do this." Fashionable Europeans once gathered in drawing rooms to unwrap ancient Egyptian mummies. It involved science, spectacle, empire, and the absolute certainty that someone at the party should have said, "Perhaps we should not do this."